Hello everyone, welcome to this video. In this video, we'll be looking at internal direct product for a collection of subgroups, right? Now we have many subgroups, namely H1, H2, H3 and so on up to Hn, right? And all of them, they are the normal subgroups of the group G, right? Then we say, and we can write G as the internal direct product of these subgroups. Whenever we have this notation, we can write it like this: G is equals to H1 cross H2 cross H3 and so on up to cross Hn, right? This would be the internal direct product of all these subgroups whenever, first of all, they all should be the normal subgroups, right? Another thing, the elements are taken such that the first element is taken from the first one, second from second one, last from last one and so on, right? And moreover, all the subgroups here, they should be disjoint to all the previous subgroups, right? If you multiply all the subgroups previous to some subgroup, say I plus 1 previous to it, if you multiply all of them I, you have nothing in common except the identity element. Why identity element should be there? Because for all of them to be subgroup, identity should be there in them definitely, correct? So this is true for all the subgroups. This is the definition how you can write it for n number of normal subgroups of G, how you can perform and write this internal direct product of n numbers of subgroups of the group G, right? So the question here is, why do we require the subgroups to be normal? This is the first question. And the second question, why we want each subgroup to be disjoint from all the previous subgroups, correct? So here the answer is simple, because in the previous case also, when we were taking only two subgroups, we wanted them to be isomorphic to our external direct product. Remember, if your G was H into K written as internal direct product, right? And if you write G as H direct product with K as external direct product, then we want both of them to be isomorphic to each other, right? In this case also, when we have many subgroups with us, then H1 cross H2 so on up to Hn, this should be isomorphic to the direct product of H1 with H2 and so on up to Hn, right? And we choose the conditions such that the two products, they are isomorphic to each other, right? This is the very simple answer as that. So I hope you understood this definition when we are talking about a collection of subgroups, right? How in that case we can construct an internal direct product of subgroups. So I hope this is clear. Well, that is it for this video. Thank you for watching.